Good morning, students. Today we will start with a new course on statistical and thermal physics. Right. Statistical and thermal physics. Here we talk about. We will start actually with statistical first. Then we say its applications in thermal physics later. As far as statistical physics is concerned, this is again the part of your science which actually deals with the study of physical behavior of a system of particles using concepts of statistics. Means we will actually deal with the physical behavior. We will actually study the physical behavior of a system of particle. एक सिस्टम ऑफ पार्टिकल है, उसका जो फिजिकल बिहेवियर है उसे we will study with the help of the concepts of statistics. Statistics is a particular mathematical tool there. Statistics आप लोगों ने पहले भी स्टडी कर रखा है, you remember in your lower classes, right? Okay. System of particles. What does this mean? System of particle. System particle का meaning क्या है या system का meaning क्या है? System means a collection of number of particles and confined in a particular region. एक particular region में जो particles हैं, right, they will form a system. Okay, we can categorize this into two different categories here. One is your microscopic system, another one is your macroscopic system. Microscopic system is one which actually contains a few number of particles. Approximately 10 to the power 3 particles are there. Right, that is a microscopic system. As far as macroscopic system is concerned, it contains a large number of particles, approximately 10 to the power 23 number of particles. That is called a macroscopic system. If we talk about microscopic system and we want to find out its physical behavior there, right? If we talk about mechanics there, we want to apply mechanics here or equations of mechanics here. Obviously, we will need a few equations here. Reason being, the number of particles are less, right? Lesser the number of particles, less the number of equations will be required there, right, in order to study its behavior. But if we talk about a macroscopic system, obviously there are number of particles are more, and obviously we need 10 to the power 23 number of equations, more number of equations, and that will become a bit complicated there in order to analyze the physical behavior of such system there, right. Okay, at this moment we need actually the help of the mathematics, that is your statistics from mathematics there, right, the particular tool, statistical tool there, right, so that we can actually have study the physical behavior of this particular system, right. Okay, or what methods we will use here. I will start with the possible methods which we will study in this course. First one is your Maxwell Boltzmann statistics, right. This actually uses classical physics. It is based upon the concepts of classical physics, and second and third, they actually make use of quantum theory there. Right. The second one is your Bose-Einstein statistics. Einstein statistics. And the last one is your Fermi-Dirac statistics. These are collectively also called your quantum statistics. The particular elements that are taken in case of Bose-Einstein statistics, these are called bosons. For example, your photon, they are actually integral spin particles, whereas in case of Fermi-Dirac statistics, the particular particles, they are called fermions. And the examples are your like electron, protons, etc., which are half integral, which actually have half integral spin there. Right. We will discuss these three statistics in details in the coming chapters. Right. In this particular chapter, we will actually focus on the particular tools which are actually required, or particular mathematical tools which are actually required in order to study these statistics. Right. The first one is your probability. We have studied probability earlier in our lower classes. Probability. What we actually mean by probability? Probability, that means by probability here we mean that we actually make a guess that what are the possibilities there. Suppose we toss a coin, and what is the possibility of a head or tail is there, right? That is called your probability, or we can say that a probability can be taken as a method of getting a better guess, right? If we talk about this head and tail event there, the possibility is the number of cases, that is 2 there. The probability of getting head is 1. The possibility of getting head is 1, so it is 1 upon 5. So favorite case is 1 here, 1 over 2, right? So it is 0.5 there. This is the probability of getting a head in a toss, and it is also the probability of getting a tail in a toss there, right? Okay, we just generalize this thing, and we say that this probability, and mathematically we can write it as probability, that actually equals to number of cases in which an event occurs divided by the total number of cases. Like in this toss event, obviously the total number of cases are 2, either head or tail, right? And the number of cases this event, the favorable event, the particular event can happen. The event, that is whether we want a head, right? If we want a head, the number of cases in which an event can occur is 1. The head can occur is 1, and the total number of cases are 2. So it is 1 upon 2 there, right? Okay. If E represents number of cases in which an event can occur, and B represents number of cases in which the event fails, then probability of occurrence of the event that will be given by the number of cases in which event can occur A, and the total number of cases, that is the number of cases in which the particular event takes place and the number of cases in which the particular event fails, that is A plus B, right? Similarly, we can write the probability of filling of event, that will come out with B upon A plus B there, right? Okay. Now we just take a bit different case here, in which we have probability. We want to find out probability of independent events. We have events, but these events are independent, right? Probability of independent events. By independent events, we mean that the occurrence of one of the event is not actually affected by the occurrence of other. Occurrence of one event is not affected by occurrence of other event or events. That depends on the number of events. If we have two events, then the occurrence of one is not affected by the second one. If we have more than one, then obviously the occurrence of one is not affected by the other, so whatever the events are there, right? Okay, we'll try to understand this probability of independent events by taking an example here. Okay, let us consider two independent events. Two independent events, right? And suppose that one event can occur in n1 ways, and the second event can occur in two ways. That can occur total number of ways. These are total number of ways the first event can occur, and the total number of ways the second event can occur. Right. Then the total number of ways in which these two events can occur. Okay. Simultaneously or one after other. That means in succession. Right. That is actually given by n equals to n1 multiplied by n2. Right. Remember this. If we have two events which actually occur independent of each other, right, then the independent of each other, and one of that occurs n1 times, other occurs n1 ways and other occurs n2 ways, then the total number of ways they both can occur simultaneously or in succession. इकट्ठे अगर करते हैं या फिर वो in succession, that means one after other, right? Then the total number of ways that will be given by and the multiplication of these two, right? n1 into n2 there. Now if m1 be the number of favorable ways, first ways for first event to occur, and m2 be the number of favorable ways for second event, then obviously total number of ways, favorable ways for both the events to occur simultaneously or in succession. That will be given by m equals to m1 multiplied by m2 there, right? Now the probability, we can define probabilities now. Probabilities probability of occurrence of first event that will be given by that will be given by number of favorable cases for first event divided by number of ways in which the first event can occur, right? That means the number of favorable ways for first event divided by the number of events, the number of ways the first event that can occur. That means it will be given by m1 divided by n1 there, right? Similarly, probability of occurrence of second event, that will be the number of favorable cases for second event, that is m2 divided by number of ways, the number of ways your second event that can occur, that is your n2, right? Now we just take as a composite system. Now instead of taking one and second event there, we just take it as a composite system, right? Where these two events they occur independent of each other, right? In that particular case, probability of occurrence of composite event composite event, that will be given by, that will be represented by, sorry, I just give some names to these two. Let this be represented by P1 and let this probability be represented by P2, and probability of occurrence of composite event, let it be represented by P. Let it be represented by capital P there, and it will come out to be the number of favorable cases when both the events they occur simultaneously. Number of favorable cases in which the particular event that occurs simultaneously, that is your m equals to m divided by the total number of ways in which these two events can occur simultaneously, that is n equals to n1 into n2. So m divided by n, and it can be written as m equals to m1 into m2. Where is that? Yes, m1 into m2, and n equals to n1 and 2, right? Can I write it as m1 over n1 multiplied by m2 over n2? But m1 over n1 is your p1 and m2 over 2 is your p2. So can I write it as p1 multiplied by p2? So total probability in case when the two events they occur independently, or when we have the particular events which are independent of each other, then the total probability or composite probability, that will be actually product of the probabilities of individual event, right? So it is p1 multiplied by p2. If we have a number of cases there, instead of just two events, we have a number of events there, n events there, right? Then the probability for occurring for n events, we can generalize now it. For n events, the probability that will be actually given by p1 multiplied by p2 multiplied by p3 up to pn, right? So probabilities, the net probability, composite probability, that will be the product of individual probabilities there, right? We just take one example to understand this, right? We just take the example that we have to draw two cards from a pack of cards in succession, that is one after other, right? Then we have to find the probability that both the cards are queens. two cards are drawn from a pack of cards in succession, and we have to find the probability that both the cards drawn are queens. These are queens. We know that in a pack of cards, the total number of cards available are 52, right? So there are 52 cards in a pack of cards. So total number of ways first card can be drawn is 52. फर्स्ट कार्ड को हम 52 वेज में निकाल सकते हैं, राइट. वी कैन ड्रॉ इट इन total number of ways. The first card that can be drawn is 52, so n1 is your 52, right. And what we want to draw is queen. So how many number of queens are there? We have 4 queens there, right. So number of favorable ways to draw a queen, or the number of favorable ways of getting a queen is 4, right. Number of favorable ways of getting a queen is 4. That is your m1 is 4, right. So probability of getting a queen in the first draw is probability of getting a queen in first draw, that is p1, that will come out to be m1 divided by n1, that is your 4 divided by 52, which will come out to be 1 by 13, right. Now similarly we have actually to draw 2 queens. Right. So we have drawn first queen, and we have simply calculated the probability of getting a queen in the first draw, right. Okay, now we have actually removed now 1 card, right. So how many cards left in the pack are 51. Earlier it was 52, one of the card that has been removed, right. Now the remaining number of cards left, that is 51. Now cards left are 51, right. So number of ways of drawing second card, that is your n2, that is 51 now, right. Now we have to check the favorable events for second queen there, right. Now number of queens left are We suppose that the first card was queen. Now the number of queens left are 3. That is actually the favorable cases now, right? So number of favorable ways to draw second queen or card that is 3 now. 3, sorry, that is m2, which is 3 now, right? Therefore probability of getting a queen in second draw that is given by p2 equals to m2 divided by n2, which is 3 divided by 51. It is 1 divided by 17 there, right? Now these two events are independent of each other. These are independent of each other. So probability of getting 2 queens as both events are independent of each other. So probability of drawing 2 queens given by P equals to P1 multiplied by P2. It will come out to be P1 is 1 by 13 and P2 is 1 by 17. So 1 by 13 multiplied by 1 by 17 comes to be 1. Right. This is the case when the problem